we're being asked to solve each equation and check for the solutions. Now on this first problem, we have 5 log base x of 9 is equal to 10. This is just slightly different than the previous examples we've done, but it works the exact same way. Our step 1 is to isolate the logarithm. Now remember, previously I said that the entire logarithm is the word log, the base, and the argument. So this is the entire log. The only thing not part of the log is the 5 in front. So you ask yourself, if I'm trying to isolate this log, what operation is happening between the 5 and the log? Well, because there is no symbol there between them, it means multiplication. Opposite operation of multiplication is division. So I divide both sides by 5. The 5's cancel on the left, and I'm left with log base x of 9 is equal to 10 divided by 5 is 2. Now that my log has been isolated, I can now perform the opposite operation. I'm trying to get the x all by itself, and right now the x is part of the logarithm. So I need to get rid of that log. Opposite operation of log is exponential. So I'm going to exponentiate both sides, meaning I'm going to create that big base. Our base in this problem is x, so I'm going to create the big base of x on both sides. And now log base x of 9 is in the exponent. So x raised to the log base x power cancels, and on the left I'm just left with 9, set equal to x raised to the power of 2. So now there are a couple ways that I can continue solving this. This is now a quadratic. Yes. So either I can solve a quadratic by getting everything on one side, putting it in standard form, and then factoring, or you can recognize there is no b value here. It's just an x squared, the a value, and the c value. Whenever we do not have a b value, how do you unsquare something? Well, you square root. So in this example, to get x unsquared, to get x by itself, we just square root both sides. The 2 and the square root cancel, and on this side, you're left with x. On the right side, left side, the square root of 9 is 3, but not only is it that positive 3, it is also negative 3. So our solutions, our plural solutions, are plus 3 and minus 3. So now I need to check my solutions. So I'm going to have to check 2 separate solutions here. The positive version of 3 and the negative version of 3. So let's start. We have 5 times log base, we're going to do positive 3 first, of 9 is equal to 10. And then we are also going to check 5 times log base negative 3 of 9 is equal to 10. Okay, so let's check the left-hand side one first. We are going to simplify this by evaluating the log. So we ask ourselves, what power do we raise 3 to equal 9? You raise 3 to the power of 2 to equal 9. So this log base 3 of 9 evaluates to be 2. And then it's being multiplied by that 5. 2 times 5 is 10. So 10 does equal 10, meaning our first solution of positive 3 is valid. Now let's go ahead and check our second solution, -3. At this point, you should have a stopping moment, because looking at this, we learned last week that there are restrictions for logs. The base and the argument can never be two things. They can never be 0 and they can never be negative. So right now, our base on this solution is -3. We can never have a negative base when we're dealing with log. So this is not a solution. It does not work. You cannot have a negative number or 0 as your base or argument. So our only solution here is +3, and the solution of -3 is what is called extraneous. It is a solution that you found that is not valid. When you check it, it does not work. So our only solution here is x = 3. This is why you have to check your solutions, because you could end up with extraneous solutions. All right, let's try one more. Number 2. We have log base 2 of x² - x is equal to 1. Step 1 tells us to isolate the logarithm. Oh, well, the logarithm is already isolated here for us. How nice, right? We have log, our base is 2, and our argument is x² - x. So this entire thing is our log. It's already by itself. Step 1 is complete for us. Yay. Step 2, perform the opposite operation. So we're trying to get x by itself. That's our goal. Right now, it is the argument of a log. So we have to get rid of that log. Opposite operation of log is exponential. So we need to exponentiate both sides. We keep the base the same. Our base here is 2. So I exponentiate by creating a big base on both sides. So log, our entire log is now in the exponent. 2 raised to the power of log base 2 cancels, and you're left with just x² - x on that left-hand side is equal to 2 raised to the power of 1. Now 2 raised to the power of 1 means you're only multiplying 2 one time, so we're just left with 2. Anything raised to the power of 1 is just itself. So now, notice, we have a quadratic equation. How do you solve quadratics? You get everything on one side, you put it in standard form, and then you look to factor. So that's what I'm going to do. I'm going to subtract 2 over and have x² - x minus 2 is equal to 0. So now we must factor this. Over to the side, I'm going to create my x. A times c goes up top, and b goes in the bottom. A times c here is -2, and our b is -1. So we ask ourselves, what multiplies to be -2, but adds to be -1? -2 and +1 multiply to be -2, but add to be -1. Now we have to check, do we have an a value here? No, we do not. So we do not need to divide by a. And these are our true factors. So I have x minus 2 and x plus 1. These are our factors. However, we're looking for solutions here. We take factors and find solutions by setting each factor equal to 0. I get the x by itself by adding 2 to both sides. So our first solution is x equals 2. Our second solution, I have to get the x by itself by subtracting 1. and x is equal to -1 is our second solution. Now before I circle these, I must check each one of my solutions to make sure they're not extraneous solutions. So over here, I have two solutions to check. Log base 2 of, now I need to plug in that 2 first. So I have 2 squared, where am I? Minus 2 is equal to 1. That's the first solution I must check. The second solution, log base 2 of -1 squared minus -1 equals 1. So I need to check both of these. First thing I'm going to do this left-hand solution. And first, on this left-hand side, I have to simplify the argument. I have to make it so it's one term so that I can then evaluate that log. 2 squared is 4, minus 2 is 2. So on this left-hand side, I have log base 2 of this argument simplifies down to 2 is equal to 1. And now that the log is all by itself with one term as the argument, I can evaluate it, just like we did last week. We ask ourselves, what power do I raise 2 to equal the argument 2? I raise 2 to the power of 1 to equal 2. So log base 2 of 2 evaluates to be 1. And that is equal to our right-hand side, so that is a valid solution. 2 that I plugged in at the top here is a valid solution. Our next solution, -1, let's go ahead and check that. Just like I did on the previous solution, I first need to simplify my argument down to be one term. So -1 squared is 1. Minus -1, that minus and negative turn into a positive. So I have -1 squared, which is +1 plus 1. It ends up being 2. 1 plus 1 is 2. Let me show that. Might be a little complicated. -1 squared is 1. Minus -1, that minus -1 turns into a plus 1. 1 plus 1 is 2. So I have log base 2 of 2 is equal to 1. Again, this is the exact same process, the exact same log as the previous solution. You ask yourself, what power do you raise 2 to equal 2? You raise 2 to the power of 1 to equal 2. So log base 2 of 2 evaluates to be 1. And the left-hand side does equal the right-hand side. 1 equals 1. So both of my solutions were valid. I can go ahead and circle both 2 and -1.